Good morning, everybody. Here we go. We are starting today factoring, and we're going to first start by factoring the difference of two perfect squares and greatest common factor. So in your first do now, we're going to multiply. You know how to do this. We could double distribute, or if you prefer to set up a box, you could do that as well. Whichever method you prefer. But either way, you get x squared, 3x, minus 3x, and minus 9. And your two middle terms, what's going to happen? They're going to cancel out. So you wind up with x squared minus 9. Your answer from the do now is an example of the difference of two perfect squares. If you notice, x squared and 9 are both perfect squares, and difference means subtraction. All right? So it's going to be very easy to factor the difference of two perfect squares. Here's what you have to know. Both terms have to be perfect squares, and there must be a minus sign in between them. So if we wanted to factor x squared minus 100, you would open up your two sets of parentheses. The square root of x squared would be x, and the square root of 100 is not 50, it's 10. So you just need a plus 10 and a minus 10. Because if you wanted to double check yourself and multiply that through, your middle terms would drop out and you would get x squared minus 100. So the nice thing about factoring is that you could always multiply in order to check yourself to make sure that when you multiply your two factors, they multiply back to what you started with. So I'm going to do a couple of examples with you. X squared minus 16. This would be x plus 4, x minus 4. And the order of the subtraction and the positive sign in the middle doesn't matter. What matters is in the next example, when you see 121 minus x squared, when you open your two sets of parentheses, the square root of 121, which is 11, must go in the front of each parenthesis. But now I can make my minus go first, my plus go second, but the x has to go to the back because that's what comes second. So now take a look at the next one, 4x squared minus 1. When you take the square root of 4x squared, you would have 2x and 2x. One's a plus, one's a minus. The square root of 1 is 1. When we kick it up a notch and we put some coefficients in front, here with the 16 and the 49, when you open up your two sets of parentheses, you have 4x would go in the front of each. It's the square root of 16x squared is 4x. And you could take a minus and a plus. The order of those does not matter. And you could put a 7y and 7y. Notice something very important about the difference of two squares. It's the exact same factor. Each of these have the exact same factor, just with different signs. Okay, exact same factor, different signs. So I am going to skip over these next few examples and let you practice those, but I'm going to go down to the greatest common factor. So if we want to find the largest number or term that divides into two numbers, we can look and figure out what is the greatest common factor that goes into both 24 and 36. So one method to do it is literally to list every single factor of 24 and every single factor of 36. So I'm going to show you just this for the first one. If I want to show every factor of 24, I could say 1, 2, 3, 4, 6, 8, 12, and 24. And if I do the same thing with 36, I have 1, I have 2, 3, 4 goes in, 6, then I have 9 goes in, 12, 18, and 36. So what is the greatest factor that they have in common? That would have to be 12. So their GCF is 12. And if I want to do the same thing with variables, x cubed is technically x times x times x. And x to the fifth is x times x times x times x times x. How many do they have in common? They have 1, 2, 3 of them in common. So the GCF here is x to the third power. Really easy way to remember it is it's always going to be the smallest exponent. That would be the least that they have in common. So let me give you some practice. If I want you to find the GCF of 3x plus 9, you're going to first find the factor, the greatest common factor between 3 and 9, and that would be a 3. And I'm going to open up now just one set of parentheses. And a really easy way to do it is divide each term by that GCF. If I divide 3x by 3, I have x. And if I divide 9 by 3, I have 3. And there's your answer, 3 times x plus 3. The nice thing you could do is take 3 times x plus 3, and if I distribute to check, I would have 3x plus 9, which is exactly what I started with. So I could do that again. The GCF between 2x minus 2, the GCF is 2, and I would have x minus 1 left in parentheses. Again, if I wanted to just do a double check and distribute my 2, I would come up with 2x minus 2, which is exactly what I started with. So I'm going to skip a couple of these easy ones and maybe just go down to something like 14c squared plus 2c. The GCF between 14 and 2 is 2. But if you look at the c squared and the c, they also have something in common. C would be the greatest common factor between c squared and c. And if I open up my parenthesis, and if I want to visualize by dividing each by that GCF of 2c, I would have 7c plus 1 left over. This is very important. When you see 2c divided by c, anything divided by itself is 1. You can't just leave it out or cancel it out, because then you would never get back 14c squared plus 2c. I'll do one more with you. How about 6x cubed minus 14x squared? That has a GCF of 2, oops, writing with the wrong thing, 2x squared. When I divide each of those, technically by 2x squared, I have 3x minus 7, and that's my answer. Let's just go down to one of these. They look a little bit different. The ones that have 3 are a little bit more difficult. Like, look at the 8xy plus 20x to the fourth y squared minus 12y. The GCF between 8, 20, and 12 would be 4. Now, do they all have an x? If you look, that last term is missing an x, so you can't pull out an x. But I can pull out a y. They all have a y in common. The middle one has a y squared, but the least exponent would just be y to the first. So now if I divide each of these by 4y, the GCF, I would have 2x, the y's divide out, plus 5x to the fourth, y, minus 3, because the y's divide out. The last one I'll show you is something right below that, which clearly you could see this is what they have in common. Their common factor is x minus 3. The other factor that you could see is 2x and plus 5. So that makes your other factor, 2x plus 5. Okay, I want you guys to try the rest on your own, and I will be posting the answer key and I will be posting a homework assignment with the answer key as well. You could always email me, or we could try to Google Hangout anything else. Okay, I miss you guys so much. Bye.